Welcome to the second part on the video of Tesla's thermal management system with OCTOVALVE. The basic system and two modes are explained in the earlier video, so make sure you watch that first. And if done watching, then let's untangle the system further. As in second mode, the heating is slow because the batteries and drive unit are limited source of energy. Plus, there is thermal recirculation via evaporator, which also slows down the heating effect. Hence, it is used to maintain the temperature and heat up only when the cabin temperature is not much lower than required. But what if the cabin is too cold and the atmospheric condition is below -10 degrees Celsius? Now, the third heating mode is switched on, which is 99% same as the second heating mode, but here, low voltage heaters are also switched on to accelerate the process of cabin heating. It consumes bit more power as it uses resistant heaters, however it's okay when you are in dire need of warmth. The fourth condition, the atmosphere is below -10 degrees Celsius and the battery is not warm enough to supply the heat to the cabin. Here only the compressor supplies the heat to the cabin, working as high voltage heater. Here how it works. In this mode, the chiller and LCC both are inactive, and the OCTOVALVE is positioned this way. The compressor compresses the refrigerant, the hot refrigerant heats the cabin. Here heating effect is equal to the heat in the refrigerant plus the energy put into compressor in the form of electrical energy, which also got converted to heat energy. Now after giving heat to the cabin, the refrigerant goes to the cabin evaporator, where after expansion it chills down. Here it absorbs back the heat it gave, but only to some extent. In the next cycle, this absorbed heat by the refrigerant in earlier cycle is put back in the cabin again. So as I told you in the example of refrigerator earlier, it's like leaving the refrigerator's door open and the system cancel out most of its energy while power consumption is still on, so it will ultimately heat the room, in this case the cabin. Heating effect is equal to cooling effect plus energy put in the system, that is in the compressor. So in this mode of heating, the heating is equal to the energy put in compressor. Fifth condition is when the atmosphere is below -10 degrees Celsius and the battery and cabin both need heating. Here the compressor again works at 1 COP, means similar to the earlier mode, but now it supplies heat to both cabin and battery. If the motors are warm enough, then it also supplements the heating of the batteries. So after compression in compressor, some amount of refrigerant goes to the cabin for heating and some goes to LCC. On the cabin heating side, it is same as earlier, but heating is slower. In LCC, the coolant absorbs the heat from the hot refrigerant. Then via bypass, it goes to chiller, where chiller is inactive. Then it goes to the batteries, where it gives its heat to the batteries for heating. Then it goes to drive unit, where it can gain some more heat from the batteries. Then from it, it goes back to the LCC for next cycle. Sixth condition. The atmosphere is below -10 degrees Celsius and only battery requires heating. As in fourth mode, the compressor worked at 1 COP in internal recirculation. Similarly, it works here, but to heat batteries. Both cabin condenser and evaporator are inactive. The compressor compresses the refrigerant, then this hot refrigerant goes to LCC. The cool coolant is heated to some extent in the drive unit, and then it goes to LCC where the coolant absorbs more heat from the refrigerant. Then the refrigerant goes to chiller and chills down after expansion, and the hot coolant also goes to chiller via OCTOVALVE. Now the cooling effect of the refrigerant absorbs the heat from the hot coolant, so cooling and heating cancels out, but not completely. Coolant still remains warm as the heating effect is always more than cooling, and thus more heat is equal to the energy put in the compressor. plus the heat absorbed from the drive unit. Now this warm coolant goes to the battery loop, where it heats the battery and itself cools down. Then it goes to drive unit for next cycle. Now let's see the 7th condition. The cabin is not being used and is warm before or after the drive. So the cabin heat is absorbed and put in the battery, which is thermally insulated, so it can store the heat for a long time, as compared to the cabin which has opening and metal glass from which the heat can escape easily. So next time when heating is required, the heat from the battery can be put back in the cabin and car won't have to generate all the heat from zero. Here how it works. It takes a lot of effort to make such content and do animations for it. By putting it on YouTube, it's nowhere near the profitability as selling reports. So make sure you support us by subscribing the channel and sharing the video, and keep us motivated by your likes and comments, then only we can keep bringing such content in future. The 8th heating mode is called Cabin Recovery Worthwhile. It's same as 7th heating mode, but it is used after the drive to absorb the heat, and the heat absorption rate here is faster. The working is just the same. The 9th condition uses 9th heating mode. When the cabin requires heating, atmospheric temperature is above -10 degrees Celsius, so the atmosphere can give heat, and battery and drive unit both are warm enough to provide heat. So the battery, drive unit and the atmosphere provide the heat to the cabin via the heat pump. Here how it works. The compressor compresses the refrigerant, then this hot refrigerant goes to the cabin condenser for cabin heating, then it goes to chiller where after expansion it chills down, then it absorbs the heat from the coolant and goes for the next cycle. The relatively warm coolant entering the chiller gives the heat to the refrigerant, so the cooled coolant comes out, which goes to the batteries where it absorbs some heat from the batteries, then it goes to the drive unit, it absorbs the heat from it, then it goes to LCC where LCC is inactive, then it goes to the radiator where it absorbs the heat from the atmosphere, then it goes to the chiller to give all this absorbed heat to the refrigerant to heat the cabin. The next condition is fogging, when defogging is required. Here's how the 10th heating mode does that. You can see the flow of refrigerant and coolant in this cycle. Here all the heat is given to the cabin and partially cooling is done in the cabin and remaining cooling is done in the chiller. The net effect is heating in the cabin. For defogging, condensation is important, so all this cool air is released over the glass for condensation of the moisture while the heat is released in the cabin. If you enjoyed this video, make sure to hit the like button, and to get notified for the next part, make sure you subscribe the channel and hit the notification bell. See you on the other side. Thank you for watching.